Good afternoon, beautiful people. Before we begin this lesson, press pause and go fill in your vocabulary for quadrants, coordinate plane, and ordered pairs. Unpause when you have finished. Thank you. Example 1. Give the coordinates of the points A, B, C, and D. To do this, start with the point A. Remember that each coordinate has an x part and a y part. The x portion of the coordinate will tell you if you move left or right and by how many. The y portion will tell you if you moved up, down, and by how many units. For coordinate A, you'll find that it is moved over to the 1, 2, 3, over to the left 3 times. Because you moved left, that should be -3. From there, you would move up 1, 2, 3, 4 times. Because you went up, you should have a +4. Do the same for points B, C, and D. Press pause while you find your coordinates. If you've done it correctly, you would have gotten 2, 8 for B, for C, 5, -7, and for D, -3, -3. If your coordinates do not match my coordinates, turn to a partner and ask them for help. Otherwise, let's move on. Example 2. Plot the points in the coordinate plane. Describe the location of the points. For J, we have the point 4, -3. Remembering that each coordinate has an x part and a y part, the x portion of it will tell me to move left and right, while the y portion will tell me to move up and down. When you're plotting points, you'll always start at the origin, 0, 0. From here, we're going to go right, 1, 2, 3, 4, and down, 1, 2, 3. Place your dot here and label it J. Similarly, for K, you're going to move left 1, 2, 3, and up 1, 2, 3, 4. Label your point K. Do the same thing for L, M, N, and O. Press pause while you do your work. If you've done yours correctly, your graph should look like my graph. Notice for point N, because x was 0, I didn't move left or right. Instead, I simply moved up 4 units. For the point O, we stayed at 0, 0 and put our point. Note, this location is known as the origin. Did you remember to describe the location of each point? To do that, refer to the quadrant that the point is in. Remembering that quadrants are numbered using numeral numbers that are Roman. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. When describing the location of the point, refer to its quadrant number. So point J is in quadrant 4. Do that for each of the remaining points if you have not done so already. You may pause while you do your work. When you unpause, the quadrant numbers will be listed by the coordinates. Notice for point N, instead of saying which quadrant it's in, because it's right in the middle, it actually lies on the y-axis. For quadrant N,
make sure that you have described its location based upon where it is. Another thing to notice is that all of the coordinates in quadrant 1 will have a positive number for x and a positive number for y. In quadrant 2, you'll have a negative number for x and a positive number for y. Quadrant 3 will have both x and y as negative, and quadrant 4 will have a positive x and a negative y. Let's continue. Graph the function with the given domain. Then identify the range of the function. Here, we will use an XY table to organize our work. For the x's, because domain refers to the x values, we'll use -2, -1, 0, 1, and 2. You'll plug in each value of x into your equation and solve for y. For example, for the first one, which is -2, instead of x, we'll write -2 and then add 4. This will give us 6 plus 4, which is 10. To plot this point, we'll go to -2, 10. Labeling it -2, 10. Fill in the rest of your XY table for -1, 0, 1, and 2. Then plot and label each of your coordinates. Pause while you do your work. Check your work with my work. I've color coordinated your coordinates so that you can see that 7 goes here. The next thing that they asked us to do is to find the range. Remember that domain deals with your input values, which are the x portion, -2, -1, 0, 1, and 2. So your range will be your outputs. That refers to your y values. 10, 7, 4, 1, and -2. Well done. Next, do the same thing for the equation y equals 1/3 x plus 2. The domain for this one is -6, -3, 0, 3, and 6. Plug in each of these values. When you're done plugging in each point, unpause to make sure that your points match my points before you graph them. You may pause now. Check to make sure that your coordinates for the y and x's match up with mine. If they do, you may plot your points now. If you're not sure why your numbers don't match mine, go ahead and check in with the neighbor to get some help. Once you're done, graph your points and then press unpause. Do your points match my points? If so, you've done them correctly. The next thing we will do is state the range. Remembering that the range is your y values. So for this equation, my range is 0, 1, 2, 3, and 4. You will not connect these dots and draw a line because they have restricted how much they want to see. They only want to see for points -6, -3, 0, 3, and 6. They don't want to know what's going on between the points, nor beyond the points. So you will not fill in this line. This is what's called a discrete function. Finally, we have a word problem. In 1990, the ratification of the 19th Amendment to the United States Constitution gave women the right to vote. The table shows the number to the nearest million of votes cast in presidential elections before and since women were able to vote. Years before or since 1920. So at negative 12, that would be 12 years before 1920. 1908. At 0, this would be equivalent to 1920. 8 is years since 1920, so that would be about 1928. The bottom portion refers to the number of votes casted in millions. So in 1920, there were 27 million votes cast in the presidential election. Part A. Explain how you know that the table represents a function. Well, remember, in order for an equation to be a function, or in order for values to represent a function, then all of the x values, or input values, have to be distinct. That means x cannot repeat for any of your values. If you were to, for example, have a negative 4 here, this would no longer be a function because you can't have two different values or output values for the same number. This is a function because all of the input values are different or distinct. Part B asks that you graph the function represented by the table. To do that, you need to make sure that you can fit all of your years from left to right, and you need to figure out where you would put your x value for all of the number of votes. Because you start from negative 12 and you go all the way to positive 12, you might notice that there are not enough squares to go from left to right. Instead, I would divide your graph in half and I would go by 2's from left to right. Do that now. Next, you look at your y values, the number of votes in millions. Our lowest number is 15 and our highest number is 40. Because there aren't any negative values, I'm going to start my x-axis down here. Draw your line now with a ruler. Very good. Remember that we should label our x's. So we'll let x be the number of years and y be the number of votes in millions. The way to note that you're going by 2's is to just mark the first one as positive 2 and negative 2. Because my number of votes goes all the way up to 40, I'm also going to go by 2's for my y values. Plot each of your points now, remembering that for 15 you'll be in the middle. Pause while you graph your points. Check your graphs with my graphs. If none of them match up, check in with the partner and make sure that you're okay. Part C says, describe any trend in the number of votes. Looking at the graph, it looks as if the number of votes increases over time. Once you've written your sentence, you may begin working on your homework. Have a good weekend, Miss Fitzgerald.